differentiate. Now, this one I put together. Sine x squared plus x with respect to x. Okay? Now, I hear talking again. Those people will get out of the class and talk to the way outside. Because I cannot stand it. There's background music outside, inside, everywhere. Okay? Alright, now let's take a look at this particular question. Question number 5. Now, if I differentiate this, it will become cosine of this, right? Times what? The differentiation of the inside. So become what? 2x plus 2y. Alright. Now usually we put the algebra in front, alright? You say that? So this will be 2. Now what do you think I have done here? I factorize out the correct. So I get this one. Everybody okay? Everybody okay? Can or cannot? Can or cannot? Can, huh? Okay, now next, part 2. Hence, you're supposed to find. Hence, find the integration I'm supposed to find this. I always box up what I am supposed to find. Because sometimes you do until halfway you forget what you want to find. You know, have you ever come across this situation? I don't know what I'm finding. Then I keep debating, I don't know what to do. Okay? You can integrate until the cows come home and it is nothing. Okay? Now, that means when I integrate this, I will get this one right. I think I'm not correct now. That's not okay. I repeat when I integrate this, I will get. Agree? But is this? No, but I can take out the constant too, right? Remember I said you can only take out constant. You cannot take out variable. Okay, so I will have this. Correct? Now, can you see this one is the same as this one? Only the one extra nonsense was it? 2. So I must divide both sides by 2, right? Okay, so I will get now divide by 2 is the same as the half, right? Okay, sine. Now you can either give me C over 2 or you can give me what? D. It's okay. But you cannot put it as C. That is why just now I want to go through that question 9 with you. Understand? Can or cannot? Can, okay? Now, so that will be your question number 5. So done already. Everybody clear? Everybody clear? Okay, good. Then, let's move on to question number 6. Now actually, for this part, right, you must know you must factorize out. If you don't factorize out, you will never get this one. Do you understand? So, when you do things, you must be alert what the question is saying. Understand? Cannot die, say, oh, it's 2x plus 2, man. There's no way I can get x plus 1, so don't do already. You understand what I'm talking about? Okay? Now, let's take a look at question number 6. Now. Okay, let's take a look at question number 6. Show that where C is an arbitrary constant. Arbitrary means any some constant, that's all, okay? Alright. Now I think I gave you a hint of it. Me, I didn't give you a hint. I didn't I got give lah. If I didn't give, sure all raise up hand one, okay? Can I clean up this orange one? Just don't no space. Can I clean up, huh? Yes. Now, some people don't know how to do this. So this one will be okay. Now, what is sine square x plus cosine square x? 1 right. So this is actually 1 minus. Now, I think in the formula list, you know sine 2 theta, or the formula list actually gives sine 2a. Okay? It's 2 sine a cos a. Now, can you see that this is 2 sine a cos a? So this one will be 2 what? 2x right? Alright, the double angle formula. So dx will be this. Okay. I saw that we are supposed to show right, so actually I'm supposed to do this right. Alright. Equal already to show already, alright? Alright, so this one, right? Alright now. Yes or no? Okay. Now. Sorry, this one will be my mistake. Just sine 2x. Thank you. Okay, now what if you integrate 1? What do you get? X. Very good. Minus. You integrate sine, you get what? Cosine. Alright now. Then must integrate, sorry, divide by the differential, right? So it's actually divided by 2, right? Then you plus something, right? I'm talking to you. You agree? Plus C, right? Understand? Okay, 4 first. Then you say 唱了. This one cannot mark, right? Okay, I'm going to rewrite here. X minus half cosine x plus c. Now, what's the difference between here and here? Can you tell me? This is cosine 2x, right? But they want it in terms of what? Sine square. Okay. Now, double angle formula. Alright? Okay, so alright. Double angle formula, yes? I cannot hear.
If you integrate sine, isn't it negative cosine?
If I integrate sine, isn't it negative cosine? Is it negative cosine? Okay, wait. I told you I never memorized, alright. So I will double check. Wait. This one all first. When I differentiate sine, I get cosine, right? When I differentiate cosine, I get what? Negative sine, right? So when I integrate sine, yes, I'll get negative cosine. So this should be a plus. My mistake. Thank you. Everybody okay? Okay? Now, if you check your double angle formula, alright now. I'm talking to you. Aiyo. Alright now. So this one I've got to put here. Agree class? Alright now. Okay, now go first. I just need to warn you on something first. Can you see the question saying finally is this one? So actually I cannot put C here. Later on it will not be C here. But you want the final one to be C. So can I put plus A first? You understand what I'm talking about? Can or not? Now if let's say exam I tell you you want to print off right, you really put plus C then you can put C1 Subscript don't go and put superscript If you put superscript then it comes 2 because C square is wrong Understand? Or this is not like the typing of a computer, okay? Alright, so I put A first one. Alright, so plus A. Now, this will be x plus half. Now, cosine 2x is this one. Correct now. So what do I have? 1 minus 2 sine square x plus A. Everybody okay? So what do I have here? X plus half minus 2 and 2 is 1, right? Sine square x plus A. So I will have x minus sine square x plus A plus half, right? Now they say show that one, right? So how? C, right? Where what? C is what? A plus half, right? You understand what I'm talking about? Yes or no? So now do you know why I never put C first? You understand what I'm talking about? Because the final one got to be C. Everyone okay? Then you ask me, must I put this one, right? Okay? It's best that you put for this particular case. Don't put, you put also, I will know lah, but it's better to put lah. Understand? If you put C, I already know that you are taking the A plus half is C with you. Everybody clear? Okay? Alright. Are we okay? So constant and constant combined become another constant, that's all. I think some of you are stuck because the one half there don't know what to do. Half is a constant, right? Constant plus constant is still constant. Everybody clear? Okay. Now, if you are done, then you can pass the work forward. So that will be your 16.2. Okay? Now, the other day, I have already done 16.3 halfway. Remember, I integrated EX. And I integrated 1 over x for you already, right? Okay, all of you take a look at the textbook. Page 107. I have done all that, right? The integration plus example 12. Example 13, I have not done. Okay? Then you turn to page 108. You can look at the integration of 1 over x. Can you see that I've also done example 14, but I haven't done example 15? Am I right to say that? Okay, so I'm carrying on with example 13. Will that be okay? Now, before I do so, right, I want to go through one simple thing. Supposing I want to integrate this. So what do I have? What's in front? 1 over 2, right? Fine. Plus C, correct? I divide by the differentiation, 1 over the differentiation. Now, do you agree that this is the same as like this? Okay, then you plus C. Okay, now next one that I'm going to show you is the integration of the fraction. Okay? Can we now turn to, okay? If I want to integrate, this will give me, everybody look up, 1 over this one will be ln this, that will be 1 over 2, right? Agree or not? I left what? Now C. Agree plus? So only when you have in this form, then you can integrate. Everybody clear? There's 5 unique partial fractions later. I'll tell you how we do partial fractions. We did partial fractions last year. Okay? Alright, now, let's take a look at example 13 first. I don't want to move so fast. So example 13 first, all of you. So this is what we have done the last time. So let's look at example 13. Okay. The gradient of a curve y equals to fx. That means I have a curve y equals to fx. At any point xy is given by dy dx equals to. Okay, that means the gradient function is this. Okay. Given that when x is 0, y is 3. That means this curve actually pass through the point 0, 3, you know. Can you see what I'm talking about here? Okay? Find the equation of the curve. Now, when you want to find the equation of the curve, that means you are finding y, right? Okay? Can we please wake Brian up? He has been sleeping since I came in. You tell him the rain has stopped. Very nice to sleep, right? I also want to sleep, I want to put a mattress here and sleep. So I borrow from the PE department. But they don't have bolster. So I should borrow from the sick bay. Then I'll ask my maid to bring my bolster here. Okay? Alright. Now, dy dx is this guy. Okay. If I want to find y, what do I do first? I integrate. Okay, oh yeah, before I forget, I missed out one question that I want to tell you just now. Yes. Can I come in now? If you have this one, 36 equals to 0. You cannot straight away put x. You must reduce to this first. Then you will have what? X plus 4, x minus 3. If you miss out this step, right, it doesn't tally, you know. Because x times x is x squared, it's not 3x squared. That's why some people put an arrow there, what is it? Because why I can press calculator and get the answer, and just plug it in. You understand what I'm talking about? It must tally. When I work backwards, it must follow. You cannot jump. Some people lucky best. After here, right, straight away answer already. Huh? That's the worst thing that can ever happen on earth. You understand what I'm talking about here? Can or cannot? I need to see this back, you know. Clear or not clear? Not clear, I remember. Because I wrote on the card, so that I remember. Then I go already, I cannot remember. So now I remember. Can? Can or can? Okay. So what nonsense am I talking about now? Integrate this one, right? Okay, right? Let's integrate. Come. Please look at me. I integrate this one. What must I put here? Just like that. Must put dx. If not, rotation minus mark. Okay, now I integrate the first one. Now, I always do this. Okay. 2, I always put bracket, then dx. So this one I can put 1 over something. So that I don't forget. Now, can you see, if I differentiate this is 1. Even if you put like that, it's not wrong. Okay? Be safer. Alright? Plus, now I have e minus x, then I have something. 1 over what? If I differentiate this, what is this? Negative 1, you know. Huh? So must be careful. That's why I always put a bracket down there. Then I plus what? C. So this will be a 2ex minus e minus x plus c. Alright? This is my integration. Okay? Now, then the question says, when x is 0, y is 3. So 3 equals to, now 2, 0, this is 1, right? E to the power of 0 is 1, please. So you have 2 minus 1 plus c. So 3 equals to 1 plus c. So c is 2, right? So what's the equation of the line, of the curve? 2ex minus e minus x plus 2. Everybody okay so far? Can you see it's the same as what we have done before? Just that now it's in terms of ex. Now, I always find putting this one in front useful, especially for cosine ex and the ln that one. You understand? So that I do not forget. Because sometimes you think it's easy, but when it's negative 1, you may forget. Understand what I'm talking about? Can or cannot? Okay, good. Next, we move on to example 15. Example 15. Partial fractions. I want to revise partial fractions first. When you do partial fractions, right, the first thing you do is to see whether the degree on top is smaller than the degree below first, right? If it's a proper fraction, then you can start, right? If it's an improper fraction, that means they are equal or more, you must do long division first. Agree or not? Mr. Square told you this, right? Okay, good. Now let's have a look at example 15. want all of you to look at this question. Don't come and give me nonsense. Put this in partial fractions. Okay, I want all of you to look up. I'm revising partial fractions. Okay, please look up. Don't copy. Don't need to copy what is in your book. Okay. What's the degree on top? 2, right? What's the degree below? It's actually 3. So, top smaller than bottom, right? So proper, can start like that. Now, do you agree this is a linear? X. X is actually x minus 0. Okay, now can you see this is a repeated linear? 2 times repeat. That means 2x plus 1 times 2x plus 1. So, when I let it be partial fractions, it should be like that, right? Repeated linear means it's still a constant. Everybody clear? Then, how do I present the answers? Now, do you agree that the LCM will be this? What is this divided by this? I'm left with A. Alright? I'm left with this, right? Then I'm left with what? C what? CH, right? Now, what have I done? The denominator is already the same. So, I have this. Are we clear? The numerator is the same. Now, then I will choose appropriate values to sub in. Understand? Now, you can also compare coefficient. Anything also can. You do half of this, half of that also can. Provided your way is correct. It is logical. Now, mind you, this is an identity. Identity is different from equation. Equation is true for only certain values. Identity is true for all values. Okay? Now, can you see I can sub in negative half? Okay, I'll look up. I do on this side. I know you are tired, but let's go on. Okay? When x is negative half, I always write down. I will have 14 into negative half squared plus 7 into negative half plus 2 equals to. Now, when it's negative half, this is 0. When it's negative half, this is 0. So I'm left with this. So it will be negative half c, right? Okay, so can someone key all this for me? What is this? I want this out. I don't want the half. What is this? Huh? 2 Okay, 2. So, C will be negative 4. Okay, now, next. If I want to kill off C and B, I choose 0. You can see it, I choose 0, 0 gone. Okay, so, when x is 0, I will have 2 equals to A into 1 square, that is 0, 0. So what is my A? My A is 2, right? Correct. Now, the last one, you can choose any number, but don't go and choose a negative number. You understand? And don't go and choose fraction. Don't go and choose 1 million. You understand? So, next. When x is 1, it's the easiest, right? Correct. When x is 1, so what do I have? 14 plus 7 plus 2 equals to A is 2, right? 2. If I have 1, this one becomes 3 square, right? Plus B, I don't know. When x is 1, 1, 3, this is 3, right? Correct. Then plus, what is C? Minus 4 times 1. Correct? Now, this side is 23, right? 23 equals to 18 minus 4 is what? 14 plus 3b, right? Isn't this 3b? So what's 3b? What's 23 minus 14? 9 log. So what's b? b is 3. Everybody clear? This is your partial fractions. Are we okay? Are we okay? Yes or no? Okay. So now I know already. What's my A? 2. What's my B? 3. What's my C? Negative 4, I can put negative here and then 4 here. Everybody clear with what I'm saying here? Okay? Alright. Now the question say. What did they say? Look at the question. What did they say? They say, hence, O-level likes this kind of question. Part A put in partial fraction. Then after that you integrate. Understand what I'm talking about? Okay, come, let's integrate. They say, hence, integrate this one. Now, do you agree if I integrate this one? It's the same as integrating the partial fraction one, because they are equivalent already, ma. Everybody okay? Am I too fast? No, so I'm going to integrate now, or look up first. Please look up. Now, I like to bring all the constants up first. So this is actually 2, right? Alright. Okay, so you put 2. Then 1 over x become ln x, right? Am I right? Then plus. What's the constant here? 3, right? Then I must have something first, right? Then ln 2x plus 1, right? Then this is a 1 over 2 again. 1 divided by the differential. Alright? Now that's the third one. Third one will be a bit difficult. Because some people do until construction cannot do it. Minus 4. This is actually a minus 2, you know. Okay, I write this. Okay? So 4. Minus 2 plus 1 is what? Remember you must plus 1? So what is it? Minus 1, right? Then you must divide by minus 1, right? Remember? Then I must still divide by 2, right? Because divide by the inside. Walao. You know, can you like you see stuff like that? Can you people remember this or not? Wait. Oh, you integrate. 3x plus 5, what is this? 3, right? Plus 1, then what? 3 times what? 3, right? So the same thing, this one plus 1 is negative 1. Then divide by negative 1 must divide by 2. Alright now? Alright now? So I plus a C, right? Now I'm going to simplify now. Now what do I have here? 2 ln x plus 3 over 2 ln 2x plus 1. Now, this one becomes what? Positive, right? Then this one becomes what? Positive 2, right? So, positive 2 over 2x plus 1 plus c. Are we okay? Are we okay? Can or cannot? Can. Can you see that this one is not easy to get? Because after you learn all the difficult one, you forget how to integrate this one. Do you understand what I'm talking about? Okay, let me ask you again. How to integrate? Tell me. 2x plus 1 minus 2 over negative 2 times 2. Must remember. Everybody clear? Okay. So, are we clear with the 2 examples? Okay, good. Alright. Next, I'm giving you exercise 16.3. What number is it on the content page now?
16.
Huh?
16.
1 5. 1 6. Okay. Okay. I'm going to give you the questions. Okay. That's all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 questions. Okay. I'm going to start now with you. Okay. Are we ready? Are we ready? Take down first. Now, I need you how to do. 1 over what? If I differentiate this, what do I get? 2 or negative 2? Can you see it's negative 2? Can you see if you put like that, will not get wrong one? Okay, so what's the final answer? This one of course is gone, right? Then become what? E minus 2x plus c. Now, I want you to rewrite this as this. X over 2 is half x. Don't stay down there and look at it forever and don't know how to do. I want to know 1 over what? Now please don't talk. What's this? Yes. Do you agree this is half? Can see it? Can you see if I write like that, I will never get wrong one. So, if it is 1 over half, what does it mean now? This is a 2, right? Correct. 2 times 2 is what? 4. This one, I want you to do it yourself. Okay, first row give me the teacher stop the video. First row give me and tell me how many.